Okay, so another example, we're looking at the limit as x is approaching 2 of 1 over x. And we want to show that that limit is 1/2, which we can see with direct substitution. So we want to find delta such that the absolute value of 1 over x minus 1/2, that end of that absolute value is less than 0.1. Whenever the absolute value of x minus 2 is less than delta. Okay, so we are going to start off with the absolute value of f of x minus L is less than epsilon. They gave us what they want that epsilon to be, how close we have to be there. And so let's look at that. We have 1 over x minus 1/2. This is less than 0.1. So our goal is to manipulate this to actually look like this absolute value of x minus 2. So it's a little harder in this case. Let's first start this by getting rid of our absolute values. And so we can rewrite this without those absolute values as a compound inequality. So negative 0.1 is less than 1 over x minus 1/2, which is less than 0.1. Okay, so that's identical. Let's now get rid of the 1/2 inside, bounded by those inequalities. And so let's add 1/2 to both sides. I'm going to treat it as 0.5 or all sides. And so if we do that, well, negative 0.1 plus 0.5, that's 0.4, is less than 1 over x, which is less than 0.1 plus 0.5 is 0.6. We don't want the x in the denominator. We want this to have an x minus 2. And so let's take the reciprocal. So remember, the reciprocal actually changes the direction of our inequalities. And so if I took the reciprocal of everything, this would be the 1 over 0.4 is now greater than x, which is greater than 1 over 0.6. So let's rewrite it. I don't like it set up like that. So let's rewrite it as 1 over 0.6. And maybe, let's see. Yeah, I don't want to just change that into decimal form. So while I'm doing this, at the same time, I don't like decimals within fractions. So I know I can get rid of those decimals within the fractions by multiplying by a fancy 1. And I need to move that decimal place over once in order to make that a whole number. And so I can multiply both the numerator and denominator by 10. And I'm gonna flip my inequality. So if I do that, this would give me 10 all over 6. This is less than x, which is less than. So multiplying 1 over 0.4 by 10 over 10, we get 10 over 4. Let's simplify that a little bit. So I have 10/6, they both are divisible by 2, so this is 5/3 is less than x is less than 10/4, they both are divisible by 2, so 5/2. We're almost there. we wanted to make it look like this. X minus 2 inside right here in the middle of our inequalities. So we're almost there. We have the x. We just need that minus 2. So as long as we subtract 2 from every side of our inequalities, we're good. Well, in order to add a number and a fraction, I need a common denominator. So basically, let's see, this is 5/3 minus 2, but my denominator is 3. So I'm going to rewrite my minus 2, if that's okay, as a minus 6/3 is less than this x minus 2 is less than this 5/2 minus 2. But in order to combine those, I need a common denominator. So this is minus 4/2. Okay, so 5/3 minus 6/3, that is a negative 1/3, is less than x minus 2, which is less than 5/2 minus 4/2. This is 1/2. Those are not the same numbers. And so we have to make sure that we choose the smallest distance. And so we have two separate things. We have this inequality right here. This is the same thing as x minus 2 is less than 1/3. Or we can think of it as this inequality right here. If x minus 2 is less than, absolute value of that, is less than 1/2. We need to choose delta to be the smaller distance. So I can either add 1/2 and subtract 1/2 from 2 and make that the interval I'm looking at, or I can add 1/3 and subtract 1/3 from 2 and make that the interval I look at. The problem is this 1/2 is bigger than 1/3. And so if I chose delta to be 1/2, there'll be some times on one side that I wouldn't hit within that L plus epsilon and L minus epsilon. So you want to choose that delta again to be the smaller number. And so in this case, we'll choose delta to equal 1/3. So if we choose delta to be 1/3, any value, again, between this 2 plus 1/3, so I'm going to just write it like this, 2 and 1/3, 2 minus 1/3, yeah. So that's 5/3. Which is 1 2/3. 1 2/3. So if we find this interval, we know that on the graph, which looks something like this, that we would be able to fall within the bounds. This would be my L value of, and we had delta, I'm sorry, epsilon was 0.1. So 0.1. So this would be L plus 0.1 and L minus 0.1. I'm trying to see if I can do this. But any number in here that we choose, we would be what we wanted within here, plus and minus this 0.1. And my stuff is not to scale, so it's a little hard to kind of to see it. But if it was drawn to scale, it would be that much better. That's the idea behind it. Can we just take the reciprocal of everything? I think we might have to be careful if it's negative and it's an inequality, but that's a good question. Just pause for a sec.